Some have been trying to get it and they haven't been able to yet. Hopefully you quote unquote should have that by next week. If you're running into legitimate reasons why you don't, that's fine. If you're just being lazy, that's not fine. Okay, so calculator, unless something weird's going on, no later than next week, you should have that. If you've not yet printed off these notes that are found in the unit 1 in Blackboard, that needs to get done as well. I kind of pay attention to that today, but I'll really start paying attention next week because it lets me know how conscientious of a student that you are or are not, so to speak. So just FYI on that. All right, so recap of Wednesday. We talked about defining a function, defining a variable, and then being able to determine what functional notation is. Okay, because again, as I spoke on Wednesday, it's all about learning the language that goes with this class. So let's say that, I'm just going to make something up. You were given this equation or this formula. And if I asked you what represents the function in this, what would you tell me?
N.
N is correct. Now, we don't know what N is. If we did, we would define further, but I just want to know that you know the letter. Okay, what would be the variable? X is correct. And then if I asked you to give me the functional notation, what am I asking for?
3x.
Do what?
3x minus 1.
That's the formula. That's not functional notation. So if you're uncertain, look back in your notes.
N at X.
It would be N at X. That's functional notation. Okay. So the function is N, the variable is X. Now the variable is always get me always within the parentheses. Those never switch. Okay. And then functional notation, when it asks for that, it's no more, no less than it's just asking for that N at X. Okay. So that's just a reminder of the language we started using on Wednesday. All right. So on number 3, we had defined the function and the variable. Again, it's been 2 sleeps since then. So let's reread it and remind ourselves what we're talking about. All right. The height of the winning pole vault in the early years of the modern Olympic Games can be modeled as a function of time by the formula. And here is the formula they give us. So in just looking at this, we know this H to be the function, which is what we defined. We know T to be the variable. Then we had looked back and we had said H is your height in meters and T is not just years, but years since 1900. And that's important. Okay. All right. So now we're going to start on part A. First thing it says is to calculate. So get your calculators out. I'm not going to always do it for you. I'm going to ask you to do it and then we'll confirm that we get the correct answer. All right. Now they give us H at 8. We know H represents the height. Therefore, what did they tell me T equals? 8. And we know that to be 8 what? Years. Okay, so just a reminder of what those numbers represent. All right, so they want us to calculate. We're going to put it into this formula. 0.4 times 8 plus 3.2. And I'm going to see that it says round your answer to 2 decimal places. So height at 8 years. What did you calculate?
It's supposed to be 0.04.
I forgot my 0. Thank you. 0.04. There we go. Thanks for catching that.
3.52.
3.52. Okay, so we get 3.52. Now it's at this point that if you stopped there and gave me that answer on the test, I would go, dang, they almost gave me the complete answer. What am I looking for?
You have to add the measures.
Which is
Meters.
meters.
Here.
So it asked me to calculate, so this would be the answer to the first question. Most students don't mind doing that, they'll just go plug it in and move on, okay? But here's the thing, it's also asking me to explain. Now, when I ask you to explain, I'm asking you to explain what does this mean in practical terms, right? So problem specific. I can't just say H at 8 is 3.52 meters. You're not giving me enough information. Also, when you are asked to explain, I expect complete sentence form. Okay, now, not an English teacher, but I can read if a sentence makes sense. Also, I'm very well aware that a sentence begins with a capital letter and it ends with a period. Okay, and you'd be surprised at how many people will not put any punctuation on their explain. Okay, all right, so this is where this information that we defined here is so very helpful. So if I'm explaining this, it starts with H and I go up and I go, what does H mean? That is the height in meters, right? And I'm thinking, okay, I need to be problem specific. So height of what? The winning pole vault, right? So I'm going to say the height of the winning pole vault. And so if I'm explaining this, then now I need to explain what that 8 represents. Now, I don't want you to just say in 8 years. That's not enough information. What am I looking for?
Since
8 years since 1990.
So what year would it be?
1908.
1908. So I want to say in 1908 was or is, right? So equals is or was 3.52. And at this point is where I will include meters. Now, does that mean you have to write it word for word how I did? No. But I am looking for that you tell me what the function is, which is the height of the winning pole vault. I need to know information about the variable, that's the 1908, and then I need the information about what you calculated, which is 3.52 meters. Okay. Now, on a test, you'll have to write it in sentence form. We're going to look at a similar question towards the end of class from a WebAssign question that it's actually multiple choice in WebAssign. But get used to writing it out because on a test, you're going to have to write it out. I don't give it as a multiple choice. Okay. All right. Part B. By how much did the height of the winning pole vault increase from 1900 to 1908? Okay. So it's talking about the year 1900 and it's talking about 1908, which we know 1908 already. We just calculated that in part A. So I'm just going to write that information down. So now I need to know what the pole vault height was in 1900. Now, this is where you need to be careful. I'm not going to do this. That would mean 1,900 years since 1900, right? So you don't ever put the year in the parentheses. The variable was years since 1900. So at the year 1900, how many years have passed? 0. So I'm going to use t equals 0. This is also what we call the initial value, what we're starting with. So I'm going to do h at 0, which is 0.04 times 0 plus 3.2. Well, I know anything times 0 is 0. So this is 3.2 meters. Now, have I answered the question?
No.
No, because it says how much did the height increase? So what am I gonna do with these two numbers to see how much it increased?
Subtract.
I'm gonna subtract. I'm going to take the value that we found at 1908 and subtract the value that we found at 1900. So that would be 3.52 minus 3.2, which would be a point, whoops, not 5.2, 3.2 meters. Now, since this is positive, I can tell that's a 3, by the way. Sorry, I about wrote a 5. Then we know what happened with that height. What was it doing? Increasing, right? Had I gotten a negative number, what would that height be doing? Decreasing. So eventually we'll talk about are things increasing or decreasing, and that's gonna be determined by we got a positive number, so we know it's increasing, as opposed to if we got a negative number, we would know it's decreasing. All right, by part C, by how much did the height of the winning pole vault increase from 1908 to 1916? Okay, again, we already have 1908. That was the height at 8 years since 1900. We know that to be 3.52 meters. So we're going to need to calculate 1916. So what is my variable in the year 1916? 16. How did we find that? We did 1916 since 1900. So 16 years have passed. So that's how we know this is 16. So 0.04 times 16 plus 3.2. Does anybody have that calculated?
3.84.
3 point what?
84
4 what?
meters.
Meters. All right. So again, 1908, I can see the number gets bigger, so definitely increased, right? So I should calculate a positive number. So in this question, we're gonna do height after 16 years minus height after 8 years. So that would be 3.84 minus 3.52, and we get the same value. And again, this is positive, so it was an increase. Okay. All right. So the next page in the notes, if you'll notice, it's kind of an overview of section 1.1. It's an extra practice. I want you individually to read through this first one, and I want you to define the function, define the variable, and then answer the question being asked. I'll give you a little bit of time to do that, and then we'll look at it together. Now, if you read it and you're like, I don't even know how to start, I'm just gonna wait on Mrs. Schamberg. No, that's why you've got pencil. Write something down. Even if you're uncertain, write down that if it was a test, what you would at least attempt. And then if you're incorrect, you can always erase it when we make the correction. But if you just wait on me all the time, you're never gonna learn to do it yourself.
You want to turn it?
If you need to flip back through the notes, do that. That's why we go through notes, and you'll have to refer back to. Now, I will tell you, this is the type of question you will see on exams. Okay, so obviously I don't necessarily expect you to get it correct. We just started learning this. But you need to, if you got it correct the first time, you're like, okay, I'm getting a good grasp on this. If you're still working on that language, then that means you're gonna have to put in extra time and maybe rework stuff until you get comfortable with it, okay? So if I was just learning this, here is a very simplistic approach that I could do. So I'm gonna give you some hints on this, all right? So I read the function n at t. All right, so before I even know what all those represent, based upon what we learned, I have two letters. My hope is that from what we've even talked about at the beginning of the class, you can tell me which letter is the function and which letter is the variable. All right, so which letter is the function? N. So that means the t is the variable. Again, always, always, always the variable will be within the parentheses. Okay, so now what I'm going to do is I'm going to go on a hunt to see how to define those. So it reads, the function gives the number of birds in a certain population t years after observation began. Oh man, they were really kind. T years after observation began, there's my lowercase. I can go, oh, the variable is years after observation began. Okay, so now I need to go on a hunt and see if I can figure out the function. And I'm like, well, let me start again. The function gives what?
The number of birds in a certain
Number of
population.
birds in a certain population. So, number of birds. And I'm gonna go ahead and put certain population. Yeah, I had a student in my 930 class say, could I put population of birds? Yes, means the same thing. Even if you just put number of birds and left off that other part on this part that you're doing, I'd be okay with that. Okay, just so we know that we're talking about number of birds and we're talking about years. Okay, now is it years since a certain date? No, but years since observation began. Okay, all right, so we've done all our defining. And it's asking me the question, explain in practical terms. I know I'm going to be writing a sentence. The meaning of in at 3. All right, so I've got to put this in word form. So here's in. Look over here and I'm like, oh gosh, that is the number of birds in a certain population. I'm going to write that. So the number of birds in a certain population. Now, let me make the point right here. Notice over here, I'm okay with you using the symbol. In a sentence, we don't put the symbol. This is not a text message. So write the word out. Okay, and then explain. All right, so we've got the in part. So now I need to finish it off with what my variable means. So what does this mean? 3 years.
After.
3 years after observation began. Period. This is the answer to the question being asked, explain. So this was not part of the answer, but taking the time to do that allows this to be a whole lot easier. Okay. All right, so number 2 doesn't have anything to do with our birds. It's a completely different question. Now 3 and 4 does have anything to do. Okay, so what I want you to do is I want you to read through number 2 and I want you to define the function and the variable. And then if I haven't started talking at that point and you want to go ahead and start answering the question, you can, but I want you to at least get that part. For some, that's kind of the hardest part, is defining those. You have a question? Sure. Yeah, you don't have to ask.
Okay.
Yeah, but thank you for checking the first time, for sure. All right, what letter did you use for the function? N. Now, that can be determined straight from going, okay, here's my formula.
Mm.
And I know it always starts with function, so that means this variable t, or that letter T is my variable.
Mhm.
Now, they were very kind in this one, weren't they?
Yes.
They said T is years since 1790, so I can go to T and put years since 1790. And then they were very kind and they said N is the population in millions. So population in millions. Okay. All right. So then let's see, that's all my information. What was the population in 1790? Okay, so N equals this formula.
Mhm.
Using functional notation, I can rewrite it as N at T equals 3.93 times 1.03 raised to the T power. And again, the most common error is for students to put in, and then they go, oh, there's my number 1790, and they put it right there. Okay, this is where you need to be careful. T is the years, so if you do that, you're saying 1,790 years since the year 1790. Okay, so this is the year that it begins. So in the year 1790, what is T?
0.
0. This is your initial population. So we're going to put 0 here. 3.93 times 1.03 raised to the 0 power. Now, you can go to your calculator and calculate this, and that's perfectly fine using your calculator. Now, I'm going to ask something, and if you don't know the answer to this, that's fine. But raising any number to the 0 power is a unique value. So whether this was 1.03 raised to the 0, or if it was 25 raised to the 0 power, does anybody know what raising to the 0 power is equivalent to? 1. Yeah. So this is actually 3.93 times 1. If this would have been 5 million and you raised it to the 0 power, 5 million raised to the 0 power is 1. Again, if you don't remember that, you can always plug it into your calculator. A lot of times students think it's 0. It is not, so be careful of that. So we get N at 0 equals 3.93, and if you stop there, I'm gonna have a problem with that. 3.93 million. In this case, if you just give me, since we have this defined,
Okay.
but hey, it's always better to have too much information than not enough. But in this case, if you just put million. And when was that? When was there that many people? When were there 3.93 million people?
Sorry, same time.
In the year 1790. So just remembering all the information given. Okay, we haven't explained, so we know we're gonna write a sentence, and it wants us to explain this. All right, so in at 20. All right. Sorry, my voice is giving me troubles today. All right, this is where taking the time to do this is so beneficial. Because I see this in and I come up here and go, oh, that's the population in millions. I'm going to be even a little bit more specific, population in the US. So I'm going to start my explain and say the population in the US what would 20 mean?
20
1790.
20 years since 1790. So if you just say the US in 20 years, that's not enough, right? Now, if you said 20 years since 1790, I would probably take that. But what I want you to do is recognize that we're talking about starting at 1790. This is 20 years after that. So what year is it?
18.
Yeah. So the population in the US in 10? And, oh, I probably should have included, I'm gonna just put it here, just so I know we're talking about millions. Because I haven't calculated it yet, have I?
No.
No, so somewhere to express that it's in millions. So this would be the explain part. That's the first part that it asks. It asks us to explain. Now it says find the value. So we're going to do in at 20. So I'm going to go find that equation, which was 3.93 times 1.03 raised to the 20th power. Now, if you don't know how to get up to that exponent, let me show you. On your calculator, so I'm going to put in 3.93 times 1.03, and now I need an exponent of 20. Look under the clear button, there is this up arrow. So I'm going to push that up to the exponent and put in 20. Now, since we're done, we don't have to enter anything else. I can just hit enter. If I needed to bring the cursor down, it would be a right arrow. But you don't have to do it on this one because that was the end of it. Okay, so here's what we get. 7.0980171152. Now, I don't see that it tells me how far to go and round my answer. WebAssign will typically specify. I'm going to go ahead and say, let's round it to 2 decimal places.
Oh.
So here's my decimal point. I'm going to go 1, 2. So that means that my answer will either be 7.09 or 7.10. Because you either leave it alone or you go up 1, and 9 plus 1 is 10, right? That's where you get 1, 0. Look to the next number. If that's 5 or larger, you round up. If this were 0, 1, 2, 3, 4, we would leave it alone. So just your rounding rule reminder. So in at 20, what would it be? 7 point what?
Million.
Now give me 1, 0 to know we rounded 2 decimal places. Even though that 0 doesn't change the value, if you just show that, it leads me to believe you rounded to 1 decimal place. So go ahead and put that 0 there. And then of course, we're talking about million. Okay. All right. This question says, express the population in 1852 using functional notation. All right, so functional notation would be in at some number, and once we know that number, that's functional notation. Am I going to put 1852 here? No, because again, 1852 is a year as opposed to representing 1,852 years since 1790. So I gotta figure out how many years it's been since 1790. So what am I gonna do?
Subtract.
How'd you get 62? You are correct.
Yeah.
Subtract 18, or you subtract 1790 from.
So I'm gonna take 1852 minus the year 1790. And that would give us 62 years since 1790. So in at 62, that is functional notation is this. So if that's all it asked for, if it just said, write it in functional notation, we'd be done. Okay, don't make more of it than it is. So that would be, if this were a test question, I would see this, that it asked you for functional notation. You've got to have this somewhere as your answer. Now, it does go on and ask us to calculate it. So I'm now going to put it into the formula. Now, again, some of y'all, you go straight to your calculator, you put it in and you get the answer. That's fine, assuming you never in your life will make a calculator error. I highly, highly, highly recommend that you show me all the values. That way, if you do make a calculator error, I can at least give you partial credit, okay? What did you find that to be, rounding to 2 decimal places?
28.4764.9972.
Wow, I don't, let's double check. Did you for sure get that 62 in the exponent? 3.93 times 1.03 raised to the 62.
Oh, 62, I did 67.
There you go. That does make a difference.
Yeah. I did 62.
Okay, so here I'm gonna go ahead and write this. I don't think anybody in this class has given me this answer, but I had a student and I get it, why they did this. So I said, let's round to 2 decimal places, and they told me 24.60. Be careful. This rounded up to 10 because we had to round 9 up to 10. This is going to be 24.56 or 24.57. Will it stay 5.6 or go up to 5.7? What? Million. Y'all, without that million, you're saying 24.56 people. That's not a very big population. So it's gotta be that million, okay? Let me think, there was something I was gonna say, and then. Oh, this is where you need to be careful. If this were a test question, I'll have students that will read this, they'll calculate, and in their haste, all we'll do is the calculate, and then they'll just only give me that answer. There'll be nothing else written on that test question. And I'll have to count at least half of it off because you did not give me functional notation. If you only answered 24.56 million, all you've done is the calculation. You did not give me everything that was asked. So I try to really point that out so you don't get in that bad habit. Okay. All right. Now, I want to show you something from WebAssign, because again, so much of this class, especially at the beginning, is getting comfortable with the language. And in notes, I write everything down, whereas in WebAssign, like I said, explain, you're going to have to write that sentence for me on a test. In WebAssign, it's going to allow you to do it multiple choice, but get in the practice of knowing how to write that sentence yourself. Okay, so if this were WebAssign, which you do not homework, you answer that electronically, you do not. Can we put phones up, please? You do not turn this in, right? You don't turn any piece of paper into me at all. Okay, but it's always a good idea, especially if this is something you're not as used to. You can always print off your WebAssign, hang on to them. They're a great resource to study from, quiz or test. Okay, all right, so let's read through this. And just to kind of get an idea of how WebAssign asks things. All right, when a car makes an emergency stop on dry pavement, it leaves skid marks on the pavement. The speed S in miles per hour of the car when the brakes were applied is related to the length L in feet of the skid mark. The relationship is, so they give me this formula. So even before I go to answering questions, I'm gonna take the time to define function and variable. Now, some of you all won't do this. You'll go straight to the questions. That's fine. I'm not gonna be by your side, but I'm telling you, if you don't get in the habit of learning how to do this or practicing it, because on a test, I will ask for these things. I'll look for them. Okay? So when I look here, what letter is my function? What letter is my variable? What's my function? S. Now notice the variable is a capital letter. We haven't seen that yet, so it can be that way. Don't just assume it's always lowercase. All right, so now I'm going to go look and see what S represents and what L represents. So right here, S is speed in miles per hour. Write that. Here, L is length in feet. Okay, so now I'm starting to wrap my head around what it's asking and talking about. Okay, so A says use functional notation. So again, it's just asking me for functional notation. But it does say to use functional notation to express the speed at which the skid mark will be 70 feet. Okay, what did they give me? Does S equal 70 or does L equal 70? L. And if I define this, I can go, oh, feet. Oh, that's my variable. So L equals 70. So how would I write that if this were a test question? What would my functional notation answer be? S at 70. So that would be functional notation right there. Now, here's what I want to show you. In WebAssign, notice it has the S for you. So don't go to this box and put in 7 and in parentheses, not 7, sorry, S and in parentheses put 70. It'll count it wrong. They've already done the S for you, so all you have to do is put 70 there. Okay. All right, then the other thing that I want to point out, or this is just calculate. I'm not going to go over that. You would just put 70 in that formula and calculate. Pay attention to how many decimal places. Okay, because if you calculated it correctly, but you didn't round correctly, it'll count it wrong. All right, the explain here is in multiple choice. It won't be on a test. But I look at this, and now my number's 110. Here's something else I want to point out. See how this is in red? Any number that's in red means that every student is going to have a different number. That will change. So the whole, hey, did you already do give me your answers. I'm going to go in and plug it in. Yeah, you'll probably get them wrong because you probably have a different number than they did. Okay. All right. So we already said that S represents what?
Speed.
That's your speed. So look, I can go here and say S at 10 is speed. Okay, it could be that one. S at 10 is the time. It's not time. I can get rid of that one. S at 110 is the speed. Okay, it could be that one. S at 110 is the length. No, it's not. S at 110 is the length. No, it's not. So you can eliminate just right there. And then the 110 represents what?
The length.
Length. Notice here, 110 meters. And if you also notice, it says meters per second here. Are we dealing with meters? No. So it has to be this one, which it says miles per hour, and it says 110 feet. So you can break it down and, sorry, I didn't have that all the way up there, and get to the answer that way too. But again, on a test, you're going to have to type it all out for me. Not type it out. Okay, so typically I would go ahead and do a little bit on the next one, but since my 9:30, we didn't get that far, I'll stop here today. Okay, so what I'm gonna do, oh wait, let me go ahead. Stop this.